Hello, Aditi.
Hello, sir.
Hello. Okay, no problem. Okay, today we'll do here standing wave, stationary wave. So today we start our standing and stationary wave. So let's see here. Where is our page? Yeah. Okay. So till now, see what we saw here. What is wave? What is wave motion? How to merge the waves? Like that is interference. Okay. And speed of the wave we saw. Okay. Types of wave we saw. Okay. Mechanical, non-mechanical, fine. Now there are some different types of waves also by amplitude wave. See, we saw that two waves, okay, fine, like types of mechanical, and non-mechanical. We saw that mechanical and non-mechanical. So this requires some medium to propagate. Non-mechanical does not require medium to propagate. So by characteristics wise, now we'll see its height wise or progressive wise. How does it progress? How does it move? How does it propagate? So there are different ways of classifying everything. So now we'll see here standing waves. Standing wave or stationary wave. So stationary, steady condition, standing, same place. That's what it means, right? So this guys, if we have two waves, if there are two waves, let's say here two progressive waves, they have same amplitude, same velocity, and time period. Then what is the difference here? It is similar to our like merging of waves. Just small difference, a very small difference that is, but traveling in opposite direction. So how to write opposite direction? By phase angle. Simple. So let's take y1 equals to a sine omega t minus kx. So opposite to that, that will be y2 equals to a sine omega t plus kx plus n minus. By this only we can say they are opposite to each other or in opposite direction. So if we make this superimpose, so by superposition by Natural superposition y equals to y1 plus y2. So if I add both, so this thing we need to just use sine A plus B formula. Sine A, sine B, sine A cos B, cos A, sine B. So there, both negative will get cancelled. So we're left with 2 A and cos kx. Kx sine omega t. So what was our actual wave? A sine omega t minus kx. So means A sine theta. So here sine theta is there, A is there, then remaining is your A term, amplitude term. So we can say here A some superimposed sine omega t. So AS is your superpositioned wave or superposition amplitude, which is 2A cos kx. Are you guys able to understand? Sudan is still absent. Okay. Akshay is there. Okay. Done. Any question? Aditi, Samhita.
No doubt, sir. No, sir.
Okay. Akshit, Shanmukh,
No doubt, sir.
Akshit.
No
You
doubt,
there?
sir.
Acha. Veda,
Yes, sir.
are you able to understand?
Yes, sir. Yes.
Okay. What about Ishanika? You cannot speak, then you just can like put your thumbs up so I can just see in chat it here itself. Okay. You can put thumbs up here. Yeah. You understood? Fine. That's it. So if you didn't understand, you can put your thumb down. So I'll understand. Yeah. Because your mic is not working. Okay. It would be easier to communicate. Okay. Chalo. Okay. This is not yet over, but you understood fine. But this is not yet over. So what we saw here, there are two ways which have same amplitude, same velocity, same time period, but opposite direction. So when we superimpose those type of waves, we get this. Simple actually. I wrote this directly, but if you want me to say a sine omega t minus 1 and a sine omega t plus 1, this this is sine a plus b formula. So sine a sine a cos a sine b, you expand both. You'll get this. If you want to try, you can do it. So then only you can. So if you try, then only you can get confidence. Yes. So if like next time in the sense like when we are doing something and I'm waiting for you to finish, and if you're done, then you can start solving those things so that you get confidence. Till then, other finished, we'll continue back. Okay. So here there is no phase angle here. Sine omega t plus or minus nothing is here. That means it is zero. What it shows, this AS is totally depending on that value. Amplitude of stationary wave AS vary with position. So if AS equals to 0, then what about this? We have to go up. AS equals to 0. What is AS? 2A cos kx. If AS equals to 0, then cos kx equals to 0. That means kx equals to, when sine will be, sorry, cos will be 0, 90 degree. So let's write here pi by 2. Next, below 90 degree, then here 3 pi by 2, and so on. If it is like this, k formula is 2 pi by lambda. Lambda is your wavelength. So therefore, if we take this value here, then x value will be, if I use this, pi will be cancelled, lambda by 2 pi in and pi by 2. So lambda by 4. Then it will be 3 lambda by 4, and so on. Did I miss anything? K x value should be pi by 2, yes, and it should be 3 pi by 2. Okay, that is correct because it is 0. X equals to, if I substitute this value, did I made a mistake? Let's see. K is 2 pi by lambda. So lambda and pi will get cancelled. So lambda is left and 2 and 4. Yes, correct only. And this also same. So this is a condition when A is 0. Now part B, AS is maximum. So if I want AS to be maximum, then cos should be maximum value. Cos kx is maximum. So kx equals to 0. Then only maximum value. Because cos 0 is 1. Then 0, then pi also, 2 pi also, and blah, 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 blah. All other blahs. Now if I substitute kx, k value here again, same way, k formula is 2 pi by lambda. So if I substitute here, then it is obvious. First term will be 0. So x equals to 0, comma. Next will be, what will be there? Lambda by 2, right? If I'm not wrong. Then pi we can cancel. So 2 lambda by 2. 2 lambda by 2. Then 3 lambda by whatever. So on. Let's forget it. Then so on. So when amplitude is 0 of stationary wave, that is called a node. These points are called nodes. These points are called nodes, where amplitude is minimum. And here it is called anti-node. Okay. But did you observe one thing here? Anything else you have observed in this two nodes and anti-node? This I'm talking about this one. Okay. Have you observed anything here? Anyone? Tell me. No one? Any of you? Aditi, Ishaneka, Akshay, Samhita, Shanmukh, Veda. Anyone did observe anything? I'm just talking about values. See the values of x.
So they are in some series.
Series, yes. Did you find any series difference in first and second one? Shall I write? Or you want to think of it?
Systematic progression, sir.
Yes. Yes. So the difference of this is lambda by 2. Here also lambda by 2. So spacing between two nodes is lambda by 2, and spacing between two antinodes is also lambda by 2. So in this case, we are getting maximum value of amplitude. X is the amplitude of this thing, right? Distance. Lambda is the wavelength. So how much long it is going, let's draw that. Let's draw this combined so that we'll understand here. I guess you're done writing, right? Only just 2 lines only writing. Okay. So if I draw one here, so antinodes, sorry, node starts from 0. No. Lambda by 4. And it is amplitude is 0. So how to mix this? 0, pi by pi and pi by 2. 2, 3. Okay, so I can draw like this. Let's start with antinodes. So this is your 2 amplitude, 2A. So this will be a 0. This is your x-axis. This is your antinode. This is segment 1. This whole. Again, segment 2. This is segment 3. And so on. So at this point, it will be node. And again, it is antinode. So this was total, how much lambda? By 2. Yeah, difference was lambda by 2. So from here to your peak value of this one, it is half of lambda by 2, that is lambda by 4. Peak value of it. Again, half of it. So we can see that distance between node and antinode is lambda by 4. Come on, finish it. Draw it slowly, properly. Then we can see here. Okay, shall we go for next? Here, next thing we will see here, that is how does it works in a string. String is also wave. It is also physical wave. When you vibrate that string, any type of string, let it be guitar string or what other music instrument, any musical instrument string or any other rope which is hanging somewhere, something, anything. Let's see here. Waves in a string.
Sir, so AND node is a maximum point, right? And node is minimum point.
Yeah,
Is that
maximum point and minimum point.
for stationary waves, the maximum point is antinode and the minimum point is node. That's it, right?
सही है, एकदम correct. For amplitude, okay? For amplitude. Amplitude is maximum here and minimum here. Whenever there is a minimum, it is called nodes. Whenever amplitude is maximum, it is called antinodes. Whenever amplitude is maximum, it is called antinodes. Whenever amplitude is minimum, it is called nodes. Like this. Antinode. So this is your half wavelength. So half wavelength, that is lambda by 4. ठीक है? चलो. Now we'll see waves in a string. चलो string देखेंगे. Now, whenever we take one wave, sorry, well, it's not writing. Okay. Whenever I take two string, so let's put some fulcrum there. So if I vibrate this one, it will go like this to like this. It will vibrate like this. So this is your distance of fulcrum L. Or as we saw here, wavelength. Yeah, distance, doesn't matter, same thing. Now, this is, मेरा fulcrum उल्टा फुल्टा हो गया. Okay, you draw straight. I have drawn like tilted. So this is your, see, whatever we are talking about, we will talk about stationary waves only now. So I'm not going to write here like again, stationary wave like this in a string. So this thing, it is fixed at both ends. Okay. Fixed at both ends. Now frequency of vibration for a one this. One second, please. Okay. This is fixed at both ends. So this is your first harmonic. First harmonic. So for first harmonic, let's say your frequency and 1 by 2L under root T by M. Now for this, how we got this? Here lambda by 2 is equals to total L. So lambda 1, let's take here, equals to 2L. So this is the reason we have 1 by 2L. Now, second harmonic. I will draw this time properly. So here 2 is, so length is same L. So here wavelengths 2 lambda 2 by 2 equals to L, which will become lambda 2 equals to L here. So frequency N2 will become 1 by L under root T by M. This is equals to 2 times of n1. n2 is equal to 2 times if I compare this two. See this? Only 1, 2 is extra. So this second harmonic is also called as first overtone. So means just at this point it is getting overtone. So here if I write here n, n, n. These are nodes here. Here this is n, n, n. So here 3 antinodes. Sorry, 3 nodes. Now same way if I go for third harmonic. Same thing, nothing difference. Just triple bounce. Third harmonic. Or second overtone. Same thing, but I'll do a little bit bigger. So let's make here 1 instead of 1, we will take here 1 and 2. Let's bounce them. Yeah. Big diagram. Alright. You guys are good in diagrams. Better do it better way. Yeah, okay. Now writing will be difficult. So here A is N, A, N, A, N. If I add here B, then it will become banana. Okay, this is your N. It's not B, but it's N. So 3 overtone. So 3 lambda 3 by 2, which is equals to L. So lambda 3 equals to 2L by 3. So frequency will become 3 by 2L T by M under root. So what the difference here we can take? 3 times. It will become 3 and 1. So here N1, 3N1, so 2N1, 3N1, and so on. So generally, if we make one common formula, so let's say pth harmonic. So P lambda P by 2 equals to L lambda P equals to 2L by P. Then frequency and P will be P by 2L, T by M, P and 1. Right? So this is your standard form. So this will be a pth overtone. Maybe not pth overtone, P harmonic. Okay, we cannot go further today for today's class because in 1 minute your class will start. You done writing, everyone? Make it quick.
Sir, could you scroll up?
Shall I zoom out so that we can see everything?